Good grade nines. Welcome to another episode of Simplifying Expressions and Fractions. So, what you must be able to do by now, you must be able to write an expression in a simpler form. That is when we add or subtract like terms. You must be able to write an expression in the simplest form by factorizing. We've done a lot of factorizing previously. And then you have to be able to apply that, both of the above, to simplify fractions using multiple operations. You already know that only fractions with the same denominators can be added or subtracted. You can add halves to halves, quarters to quarters, but not halves to quarters, unless you change to the same denominator and write it as equivalent fractions. You also know how to multiply fractions. And when we multiply fractions, we multiply numerator with numerator, denominator with denominator. An example, if I have 3 over x times x squared over 4, I'm going to multiply 3 with x squared and x with 4. Numerator times numerator, denominator times denominator. When we divide with fractions, that you also know, it means that we multiply with the reciprocal, which means we times and tip. So, for instance, if we have a half, divide into quarters, we write it as a half. Times become, divide becomes times, and we tip the quarter and write it as a reciprocal, where the numerator becomes the denominator and the denominator becomes the numerator. And now you just multiply like you ordinarily would. And that will give you 2. And that is obvious. 2 quarters will go into a half. So a quarter go into a half twice. Right, that is the introduction. Right, everybody, we're simplifying fractions. And we're going to use everything that you've learned in the past weeks. So we're going to look at a few examples. So my first example, simplify the fraction where we have x plus 2 over 2, divide by x squared minus 4 over 2x minus 4. So the first thing you need to do, what are we doing here? We're dividing a fraction with a fraction. So when we divide, what is the rule? And do this first of all. Then you won't forget to do it later. So with other words, I'm going to first rewrite this. There's my fraction. And I'm dividing, which means now you are going to multiply. And you're going to multiply with the reciprocal of the fraction that you divide with. With other words, the numerator, which is 2x minus 4, the denominator will become the numerator, and the numerator will become the denominator. Which means we times and we tip. So, now let's look at what we've got. This is a simplified fraction. There's nothing here. You can't divide 2 into it, so we can't do anything with that. But let's look at the second fraction. In our numerator, we have 2 terms. So look at the 2 terms. Can you spot what you can do here? Yes, there is a highest common factor. So I'm going to take out the highest common factor. So let's do that. Let's rewrite the first fraction. I can't do anything with that at the moment. And I'm multiplying. The numerator of the second fraction is a 2-term expression. It can be simplified by factorizing. And we do that by taking out the highest common factor. So what will be left in the bracket? 2x divided by 2 is just x minus 4 divided by 2, which is 2. And I'm dividing it, so now look at the denominator. Yes, it's a square number minus a square number, which means you have a difference of 2 squares, which means this can also be factorized. So let's do that. So I'm going to get the square root of the first term, which is x, plus the square root of the second term, which is a 2, multiplied with the square root of the first term, opposite signs because you don't want the middle term, minus the square root of 4, which is a 2. So now, this is 1 term over 1 term, 1 term over 1 term. So I can basically write all of this as, let's put the x plus 2 in a bracket, and I'm multiplying with a 2, and I'm multiplying with an x minus 2, and under the line in my denominator, remember I'm multiplying all of this, numerator times numerator. Under the line I have 2 times x plus 2, x minus 2. So now I have one single term in my numerator, one in my denominator, and this is what we've been doing. How can I simplify it? I can divide with the highest common factor. So what is common? This 2 can divide into that 2. That can go once. And this bracket x minus 2 can go into that bracket x minus 2 once. And there's another factor that's common. That x plus 2 can go into that x plus 2 once. So what is my answer? 1 times 1 times 1 in my numerator, 1 times 1 times 1 in my denominator, which means my answer is simply going to be 1. And my fraction is factorized. So let's look at the second example here. Again, now I'm multiplying. I'm multiplying this fraction with this fraction. So if I look at the first fraction, can you see it's simplified? You cannot do anything there. But if I look at the second fraction, and guys, you must spot this. There's a square number minus a square number, which means it's a difference between squares. In my denominator, I have 2 terms, and voila, there's a highest common factor. So I don't want 2 terms over 2 terms because, like you've seen before, you can't simplify that. So I'm going to factorize both so that I just have 1 term in my numerator and 1 term in my denominator. So let's do that part. So I'm going to get x plus 1 for my first fraction over x minus 1. And I'm going to multiply it with the factors of the numerator, which is 2 brackets, because it's a difference between squares, square root of the first term, which is x, opposite signs, because I want the middle term to fall away, square root of the last term, which is a 1 and a 1. So the numerator is factorized. Under the line, in my denominator, I have 2 terms, and I have a highest common factor. So I'm going to take that out, the 2 out, divide the 2 terms with the 2. I get 2x divided by 2 is just x, plus 2 divided by 2 will be 1. So now I've got 1 term over 1 term times 1 term over 1 term. And let's put this in brackets because they form separate numbers. So, rules of multiplication with fractions means numerator times numerator, denominator times denominator, or I can simplify if I divide with the highest common factor above and under the line. So do you see highest common factors here? There's a number x minus 1. Can you see it's the same as that one? Which means this bracket x minus 1 can go into that bracket x minus 1. It will go once. And then here, there's a x plus 1 that can go into that x plus 1. So this bracket can go into that bracket once. Is there anything else? I don't think so. So what am I left with? In my numerator, I have the bracket x plus 1 times 1 times 1, which is just going to give me x plus 1 over, and in my denominator, I have 1 times 2, which is just 2, which means that is as simple as it gets, and it is done. Right, that's 2 examples. So let's go a bit further now, and let's look at free terms. In your numerator, what do we do with free terms? So we're going to say, and I'm dividing now as well. So a trinomial, 3 terms in the numerator, 2 terms in the denominator. I'm dividing with a fraction, so let's just rewrite this first before we forget to do that. So I'm going to get 6x squared plus 18x minus 60 over 8x squared plus 40x, and I'm going to change the divide to a times, and I'm going to flip this around so that the denominator becomes the numerator and the numerator becomes the denominator, and I have this. And this fraction is already simplified. You can't do anything there. So let's go to the first fraction. In my numerator, I've got 3 terms. We want 1 term because otherwise we can't simplify and take out highest common factors. So the first thing that you need to see here, there is a highest common factor in this expression. So I'm going to first of all say the highest common factor of 6, 18 and 60 is actually 6. So I'm going to take the 6 out. Then I'm going to be left with 6x squared divided by 6 is just x squared plus 18x divided by 6 is 3x minus, and 60 divided by 6 will give you 10. So let's look at the denominator now. There I also have a common factor. Do you see that? 8 can go into 40, and there's an x. So I can take out 8x as a common factor. If I divide 8x squared by 8x, I'm going to just have x plus, if I divide 40x with 8x, I'm going to get 5. So that is factorized, and I'm still multiplying with the other fraction, 8x over x minus 2. So now let's look at what is in the bracket here. It's a quadratic expression, which means that it can be factorized. So let's do that. So I'm going to look at my first term of my trinomial, which is x squared. So I know that x times x will give me x squared. And I'm going to look at the last term. Factors of 10, if I add it, if I multiply, I must get a negative. But if I add, I must get a plus 3. So factors of 10, 1 and 10 is not going to work. But if I look at 2 times 5, the difference between 2 and 5 is 3. So I can use them. So let's just see. I'm going to use 2 and 5. But if I now multiply, it must be a negative 10. And if I add, it must be a plus 3. So the biggest factor must be positive. So it's going to be plus 5 and a minus 2. Because minus 2 times 5 give me minus 10. And 5 minus 2 is going to give me the 3 in the middle. So my brackets, there's my brackets. So let's rewrite this whole story. And I'm going to get 6 times my 2 brackets for my quadratic expression, which is x minus 2 in the first bracket. and x plus 5 in the second bracket. And I'm dividing with 8x times x plus 5. Do you see all the factors that are common? And I'm multiplying all of that with the 8x. Let's put the x minus 2 in a bracket as well. So let's see now. Do I have common factors? And it's clear that we do. I can simplify because this x plus 5 can go into that x plus 5 once. The 8x can go into that 8x once, so that is gone. And then this x minus 2 can divide in that x minus 2 once. And that is it. So what is left? It's only the 6 times 1 times 1 times 1 in the numerator, which will give you 6. Over 1 times 1 times 1, which we don't write. So my answer is just going to be 6. Finish and klaar. And that is 3 examples. I hope it will help you with the exercises in worksheet 4. Have a nice one.